Okay, so today we're going to continue our discussion of percent composition, and we'll talk about empirical formulas today. So again, our ultimate goal is to be able to convert from percent composition into the actual molecular formula of a compound, and we can talk about the applications that has in forensic chemistry when we complete this. But today we want to look at how to calculate the empirical formula of a compound. So first we have to talk about what is an empirical formula. So before we can describe that, we need to be sure we're familiar with the term molecular formula. Okay. So molecular formula is, as you could probably guess, the formula of a molecule. So something like H2O, okay, CO2, H2O2. Okay, those are all molecular formulas. So an empirical formula, and I'll abbreviate that EMP formula quite a bit, is the most simplified, most reduced form of that formula. Okay, so in some cases, empirical and molecular formulas are the same. So there are 2 hydrogens, 1 oxygen here. I can't reduce that. So the empirical formula for water is H2O. The empirical formula for CO2 is CO2. However, H2O, there are 2 hydrogens and 2 oxygens, so I can reduce that. Okay, so the empirical formula for H2O2 is just HO. So a molecular formula could be N4H2. Okay, and I'm just making these molecules up. So the empirical formula, if this is the molecular formula, would be N2H. Okay, so we reduce that. So if you notice here, the empirical and molecular formulas will have the same percent composition if we break it down. So that's why they're a little bit tricky, okay? So if the percent composition can be the same, we'll need a little bit more information to go from percent composition all the way to molecular formula. So today what we want to look at is how to convert from percent composition to empirical formulas. Okay? So this isn't a super helpful thing in itself, because the empirical formula might not even actually be the molecular formula. But then after we do this, we can convert from empirical formulas to molecular formulas. And that will actually allow us to determine the identity of molecules. So, but for today, we want to look at this first step, just converting from percent composition to empirical formulas. So in today's examples, the percent composition will be given. So we calculated it in the previous video, but today we're just given that percent composition. So in these situations, the percent composition was found through some sort of experimental analysis. Okay, so an instrument was used and it told us the percentage of each of the atoms present in the molecule. Okay, so let's go ahead and list out the steps for converting from percent composition to the empirical formula. So first, you change percentages to masses. Okay. So we take a little shortcut here, and this conversion might seem a little strange, but we can actually just change the percent sign to a gram sign. So in this situation, we can assume that if we have 95%, we have 95 grams. The reason why we do this is we assume a 100 gram sample. Is our sample actually 100 grams? No, it's not. But a 100 gram sample and a 2 gram sample have the same percent composition, okay? So it doesn't really matter what sample size you assume. So if you want to do it with, a 17.4 gram sample, if you just want to randomly decide that number, you can convert from percentages to grams by multiplying the percentage times 17.4. That will be dumb though, okay? We're going to assume a 100 gram sample to make our math easier. We'll get the same answer in the end, because 14% of 100 grams is 14 grams, okay? 12.5% of 100 grams is 12.5 grams. So we'll always assume 100 grams. Just keep in mind though that units percent and gram are not equivalent. Okay, they're only equated here because we assume 100 gram sample. So the second step is convert from grams to mole. Okay, so remember how to do that using dimensional analysis. So our conversion factor for our gram to mole, of course, is the molar mass. So then the third step is we want to divide all the number of moles by the smallest number of moles. Okay. So as we often do in this class, let's copy the steps down first, then we'll talk through some examples together and hopefully the steps will make more sense. And then the last step, we want to convert all numbers to whole numbers. And I know that step makes no sense. So like I said, we'll go through some examples and the steps will make more and more sense. So let's go ahead and look at the first example in the notes. Okay. So